Okay, so this one is the session number 6 on numerical method, finite differences. So let me see the today's agenda. The three things you are going to learn today. So first thing that we have to find out higher order differences without a difference table. In the last session, we prepared the difference table and whatever the differences we require, just we are highlighting from that table only. Okay, but without preparing difference table, also we can find out these higher order differences that we can see it here. And the second, then you will see the definition of a factorial notation for a polynomial. Okay, it is not like factorial of number, it is factorial of a polynomial there. And lastly, we are going to express this polynomial in the factorial notation. Okay, and then we can find the differences of the polynomial. Okay, so first thing, we are going to express the given polynomial in a factorial notation, and then we can find out the differences of a polynomial. So differences, already we learned, these differences is exactly similar word to the derivative there. Okay, so that are the three things you will learn it right now. So the first example right now we have, using delta equal to e minus 1, show that or find delta cube y2. So third order derivative we have to find out with the help of this relation. Okay, it's a very simple small thing that we require here, and that is a binomial expansion. Let me see how many of you can expand the bracket. So see the solution. Solution is we have to find out. The question is find delta cube of y2. What is the delta? By relation, we already proved this relation in the last session. The delta is nothing but it is e minus 1. So e minus 1 bracket cube of a y2. Now I want this bracket cube of this one. Actually, this is up to square and cube. You have the formulas, you can directly write it. But after that, you can use a binomial expansion of this bracket. Yes, can anyone tell me the expansion? It should be
NC0.
Okay, directly bracket. This is bracket cube, na? So without expansion, Ankit. Is it a cube minus 3a square b? Is it 3 square into 1 plus 3e1? Alternate plus and minus is there. 3e1 square, sorry, minus 1 square, and minus 1 cube. Is it?
Yes, sir.
Okay, so it is just like a cube minus 3a square b plus 3ab square minus b cube, that way. Okay, so that way we can expand the a minus b bracket cube. Now only a last step here. Can you tell me what is the e cube of y2? Let me see. E cube of y2.
Y5.
Why? Is it y5? So this just 3, this y2 will be shifted to the y5 because 2 plus 3. This is a power 3. Y2 plus 3, that is y5 there. So the first one, or I will write it step by step so that you will get this step. Otherwise later on you will think how this appeared. So e cube of y2. So the first term will come e cube of y2 minus 3e square of y2 plus 3e of y2 and minus y2. So the last step I will take it here now. E cube of y2 is y5 minus 3. What is this? Y4 plus 3 y3 minus y2. And this is the delta cube y2, delta cube of y2 in terms of the given values of y1, y2, y3, y4, y5. Suppose you have that given values y1 to y5 or y0 to y5, and we want delta cube y2. So these values we can use it to get the value of delta cube y2. Got it? Any doubt?
Sir, can you explain the Wi-Fi thing?
Wi-Fi thing, yes. See, there are two ways of this notation. The first you learned E of fx. What is E of fx? Yes, this we learned in the last session. Shift operator. E of fx is f
F
of
of x plus h.
X plus H.
correct, x plus h. Now this similarly you can say E square of fx is f of x plus 2h. F of x plus 2h. This you learned in the last session. But remember, there are two ways of writing this. So when we have x, x plus h, x plus 2h, and so on. So we can write this as fx, f of x plus h, f of x plus 2h. So the function is given in this form. But generally we say y equal to fx. So y equal to fx. So suppose this is said as a y1. y1 is y equal to fx. This is y2. This is y3. And this is y4 and so on. So that way. So sometimes the notation, instead of giving in f of x notation, we use y1, y2, y3 also. So y3 is nothing but f of x plus 2 is that way. So exactly same thing. So if you take e of y1, so we have to shift one place to the next here. E of y1 is y2. Okay. E square of y1 is 1 plus 2, that is y3. Got it? Is that clear?
Yes, sir.
Okay. Yes, sir. So that's so simple, but yeah, notations are only different there. Okay. So this way we can prove it. Okay. So come to the next here, next example then. And here we are going to find higher order difference. We want fifth order difference. Fifth order difference of u0. Fifth order difference of u0 without difference table. Without difference table. So the trick is whatever we done in the last example. Instead, as we are not interested to make a difference table. So to get fifth order difference of u0, there are two ways. We can make a difference table, and in the difference table, the first is a leading row. First leading row you will get as a delta u0, delta square u0, delta cube u0, delta 4 u0, and delta 5 u0. And that last entry in the first row will be the delta 5 u0, and you get that answer. But here the question is without using a difference table. So we have to write a binomial expansion here first. So we can consider in a solution delta 5 of u0 is equal to delta is e minus 1 raised to 5 of u0. Now we want the fifth power of the bracket, and now here this is not a formula. You should know the binomial expansion. Those who are not good in calculating the binomial coefficient, remember on the calculator also you will get this coefficient there. Okay, so these are very simple. First one is 5c0 e raised to 5. What is 5c0? Or I will write it.
1.
Yes, first I will write it, and next step we will take e raised to 5. Now remember there is alternate plus and minus sign. So first term is plus, second is minus. 5c1 e raised to 4 plus 5c2. Just decrease the power of e throughout, e cube, plus there is power of 1 also, but no need to write it because 1 raised to n is 1 itself. So we are not writing it. So minus now 5c3 is it e square, then plus 5c4 e, and lastly minus 5c5 e raised to 0, no need to write it. So of u0. Now we'll write the values. 5c0, yes, already I got that as 1 e raised to 5 then. What is 5c1?
5.
5, correct. Next, what is 5c2?
10.
Very good, 10, correct. Then 5c3,
10.
yes. Now remember the binomial coefficient are symmetric about the center. Now these coefficient 1, 5, 10. Now 10, 5, 1 go on decreasing order. So they are always symmetric. So 10, 5, this is e square, correct. Then 5e and minus 1 of u0. Now last step. Can you tell me e phi of u0? What should be? E phi of u0.
U5.
U5 directly. Yes, 0 plus 5, U5. Minus phi u,
5.
10 minus 10 U2. That's one. So this is the step number one. We arrived at delta phi of u0 is this expression. Now all these values are given. You can observe all these values are given in the question itself. U5 is given as 8 minus 5 times U4 is given as 100. U cube U3 sorry U3 is given as a 200. U2 is given as 81. U1 is given as a 12 and U0 given as a 0 only. That's one. And do this calculation on calculator and cross check whether you get a 7, 5, 8 as a required answer. Important part is a binomial expansion only. The binomial expansion of that a minus b bracket raised to 5, or here e minus 1 bracket raised to 5 there. Remember these questions, this question is not asked in last 5-7 years in the final exam, this type of question, but it is part of a syllabus.
Yes, sir. Getting 758.
Okay, good, very good. So can we move to the last part then? Last part of the...
Yes, sir.
Okay. So the next part that you are going to learn is about a factorial notation first. And then we have to express the polynomial in factorial notation, and we have to find the differences of polynomial. So that about the next part we have. So this is the factorial notation. Remember, we have the factorial for the numbers. We know the n factorial is given as n into n minus 1 into n minus 2 into so on up to 2 into 1. Okay, like this. So this is the factorial for a number. Now factorial for the algebraic term x is factorial of x. Okay, this is the notation. I will just erase everything and I will write it. This is a you can read like x factorial. Okay, x factorial is x only. Second factorial of x. Second factorial of x is x into x minus 1. Third factorial of x. You will observe third factorial of x. This is a third factorial of x, which is x into x minus 1 into x minus 2 and so on. But generally in all the questions, whatever the examples we have in the syllabus here, they are up to the third factorial of x. So that is enough. So up to cubic polynomial, I will say. So these things we require. It is better you should remember this in multiply. If you simplify this x into x minus 1, you get x square minus x. That also, if you remember, that's better for calculation purpose. This is x cube minus 3x square plus 2x. That is the third factorial of x there. Now, what is the benefit when we write a given polynomial in a factorial notation? The differences will act like a derivative. The differences will act like a derivative, and just by the derivative formula, we can get the difference of that function f(x). Okay, so that is only the thing that you should remember here. So we'll come to the question, then it becomes more and more clear. So first, you have to remember these three things, that x factorial is x only. Second factorial of x is x into x minus 1. Third factorial of x is x into x minus 1 into x minus 2. That's one. So the question is, we are given a cubic polynomial 2x cube minus 3x square, 2x cube minus 3x square plus 3x minus 10, and we have to write it in a factorial notation, and then we have to write a third difference of that polynomial. So to get a third difference of this polynomial, we are just going to take a third derivative of that polynomial, and we get a required answer there. So a solution go like this. We are given y is equal to 2x cube minus 3x square plus 3x minus 10. Now I want this x cube in third factorial of x. So start with the highest degree there. So this 2 will be as it is. Now can you tell me first what are the terms we require for this one, third factorial of x? So I'll write it here. Can you tell me what is the third factorial of x? Yes. X cube
X cube minus 3
minus
Minus
3x
3x
square plus 2x.
plus 2x, is it?
2x.
Only this much? X
Yes.
cube minus 3x square plus 2x, correct? Okay. So we want that these terms here. So we are going to adjust it. I will write it here x cube minus 3x square plus 2x. Which are the extra terms we are taking here? Which are the extra terms we are taking? See, 2x cube is as it is, so that there is a 2x cube. So here is minus 6x square, but there is a minus 3x square only. So what should be the adjustment here? Plus, is it visible this color?
No,
Yes,
sir.
sir.
Okay, few are saying yes, few are
Yes,
saying
sir.
because I think background is not good. So otherwise I will take this. All are like that only, but see here, this is a minus 6x square. Minus 6x square we adjusted as a plus 3x square. So you get required minus 3x square only. So what should be the remaining adjustment? This is a plus 4x, but there is plus 3x. So what should be?
Minus x.
Minus x. And last minus 10 will be as it is. I hope you got what I'm saying. So the first term, this 2, this term now I can write it as a third factorial of x. Okay. Plus 3x square minus x minus 10 as it is. So only this first bracket is written as a third factorial of x. Similarly, recall the second factorial. Recall the second factorial of x. What is the second factorial of x?
X square minus x.
Correct. X square minus x. So if I want to do this x square minus x, 3x square is as it is, minus 3x will be there. So what should be the adjusted term?
Plus 2x.
Plus 2x. Good. And now the last step will come. So we got a factorial notation. I will say thus y equal to y. I will write it with this king so that y is equal to 2 third factorial of x plus 3 second factorial of x plus 2. What is the first factorial of x? It is x itself. So can I write like
Yes, sir.
this? And that is the end of the first part of the question. We expressed, okay, we already expressed this polynomial y in a factorial notation. Now this is in the factorial notation, and we want a third difference. Remember, to take the third difference now, just we have to take a derivative of the RHS. And this first derivative of x cube, we know 3x square. That way we have to take a differentiation. So this gives us first difference of y, delta y. 2 into 3 is a 6. 6 second factorial of x. I hope you are getting. Plus 6 first factorial of x and plus 2 only. Derivative of x is 1 and derivative of constant is a 0, that way. So this is the first derivative, first difference. Actually this is the first difference. That differences will act like a derivative. Okay, act like a derivative whenever we write in factorial form. So delta square y, now second derivative. So it is a 12x plus 6, that's one. And the third derivative, that is a question, or third difference is a question that we want, and that is just a 12, and that's the answer. You can highlight this as answer here. There are two answers. The first one is the factorial notation, and the second one is the third difference of that polynomial. That is the end of the question here. Anyone have any doubt here?
No, sir.
Okay, good.
No, sir.
Okay, so Remember, the most important thing you should note down, when the polynomial is given, when this polynomial is given, a higher degree coefficient and the constant coefficients will be same in a factorial notation. So highest degree coefficient is 2, so which is appeared 2 itself, and the constant term minus 10 will appear minus 10 as it is. So this always happen whenever you write any polynomial, whenever you write any polynomial in its factorial notation, highest degree coefficient and constant coefficients are always same. Only middle coefficients will change. Here is a minus 3x square, it become plus 3 second factorial, and here is plus 3x, so it become 2 times first factorial. So middle terms have the different signs there or different coefficient. Okay, so last question here. Find the function whose first difference is this one. So whenever we have to find out the function whose difference is like this, we have to write that function first in a factorial form. Okay, because once we get a factorial form, we know this is the first difference, this is the first difference. We can integrate, because derivative and integration can be applicable for factorial function. So okay, factorial function, whenever the question is about the difference, come to the given part. So our aim is to get fx, our aim is to get fx, or our aim is to get y equal to fx whose delta fx is this one. So indirectly, what is the part? Given part is delta fx, where given the first difference, whose first difference delta fx is given as 9x square plus 11x plus 5. And now what we want? We want fx. We want fx. So actually we have to integrate. But if you integrate this directly like this, like 9x cubed by 3 plus 11x square by 2 plus 5x, it may not be correct. Okay, or definitely it is not always correct there. So what we have to do it first, we have to write this in a factorial notation. So delta fx as it is. Can you tell me what is a formula for second factorial of x?
X square minus x.
Correct. It is x square minus x. So what should be the adjustment? 9x square minus 9x is
Plus
there.
20.
Correct. So what is the factorial notation then? 9 second factorial of x plus 20 first factorial of x plus 5. That's one. So we got delta fx. Therefore, integrating, just previous time we differentiated because we want the differences. When we want a differences, we integrate it. And from differences, when we want a polynomial, we integrate it. Okay. So fx equal to, what is the integration here? 9
3x cube.
x cube by 3 plus 20 square by 2 plus 5. To simplify, so fx becomes 3 third factorial of x plus 10 second factorial of x plus 5 first factorial of x. And now we want that function, this is the factorial notation. So again we have to simplify this. So you have to write like sorry, 3 times this is a x cube minus 3x square plus 2x, is it, plus 10 x square minus x plus 5x. And now if you simplify this, you will get a required function. I hope you are getting what I am saying. Pardon?
So how do you know there wasn't
Harsh, yes.
so how do we know there wasn't a constant in the function fx?
How there is a constant in the, yeah, so that is a mistake. Yes, when we integrated, we forgot it to write the constant of integration, so we should say plus c there. So plus c, you can write it everywhere. When you integrated that factorial notation 5 factorial of x, you can say plus c everywhere there, not a problem. Any doubt?